All right, let's go ahead and talk about 21, 22, 23. Very important conceptual ideas in 21 and 23. So what happens is with 21, we say that we know we have something that is statistically significant. So I'm going to use this little red dot to represent my sample that is statistically significant. Now it says it is statistically significant at the 10% alpha level. So here's my alpha of 10%, okay? And then I'm going to color this area blue. And so that means that my sample is somewhere in this blue region. All right? Now, the question is it always significant at the 5% level? Let's take a look at this. 5% level, we'll put that alpha here. And so that would make it this area here. Okay? And so the question is this red dot always in the rejection region for red just because it's in the rejection region for blue? And so then the answer to that is not necessarily right here. So the sample is, while in the rejection region for 10%, because it's stated it is, does not necessarily mean that it is located in this rejection region for the 5%. Okay? Now, the other ones are simpler answers. Of course, here with this alpha of 10%, of course, it's in the alpha of 10%. That was stated in the problem. But then we also wonder, is it significant at the 20% level? Well, if we take a look at that, here is your alpha at 20%, and that is all of this area here. So what happens is, if your sample is in the blue area, then it automatically is also in the black alpha of 20% rejection region. Okay, so red, not necessarily, but blue, of course, because it said it was. And then if it's in the blue, then it's automatically in the black. One other way to think about it is this. If you are in the top 10% of your class, are you in the top 20%? And that answer is yes. If you're in the top 10%, you are automatically in the top 20%. You told me I'm in the top 10%. Are you in the top 5% of the class? And that answer is not necessarily. All right, 22 is just the definition of margin of error. I want to give you a visual of that. The margin of error is when you have your sample p hat. Margin of error is that area that you go up to the upper bound and then down to the lower bound. So this here is the distance of the margin of error. All right, the range above and below that sample statistic, that p hat for us right now here in the middle, and that creates the confidence interval. All right, last one, number 23. This one says that it is defined as having an alpha of 0.12, okay? So the size of the rejection region is 0.12. Now, the question is, though, if you have a null hypothesis of 0.4 and an alternative of greater than 0.4, what that is saying is you have an upper tail, and that is a one-tail upper tail. Well, if your one-tail upper tail is right here, and the entire rejection region of 12% is located in this upper tail, then I can determine the critical value. That's what it asks for. I can find the location of this z star by doing inverse norm of the area below is the z at that point. So inverse norm of the 88% below is 1.17. So this here has a critical value of 1.17. Okay? All right, next. However, if we have a lower tail alternative, well, if we have the lower tail alternative, then that's putting all 12%, so this one tail, lower tail, in this bottom section. And so then the question is, what is the location of this critical value? Well, it's going to be the symmetrical other part than part A. But it comes from inverse norm of the area below, which is 0.12. And so that is at negative 1.17. So therefore, critical value for that one is negative 1.17. Here's when it's a little different. C says the null P is 0.4 and the alternative is two-tailed. That means that your alpha of 0.12, your rejection region, is being split between an upper tail and a lower tail. And if it's being split between the upper tail and a lower tail, there's 6% in each one of those tails. So then, after you know that, you go about finding the location of this critical value, and that would be inverse norm of the area below. Inverse norm of the area below is the z at that spot, and so that's negative 1.55. And of course, I know this one is the mirror image, so that's the positive 1.55. So that's what's going on with that number 23.